In this, we are going to find out with a given figure, and we are writing the conditions for the sets language for the three sets. And also, when the conditions are given, you are going to write down the shaded region of that part there. So there are two steps in this. So first of all, the figures are given and you have to write down the conditions and shade the region accordingly. First of all, let's say the given figure is this shape. Now you are writing the conditions for this part as A intersection B union C. Before explaining this topic, let me explain one thing which will make it clear to you that how the region is going to be represented or shaded there with the help of the numerics number. And when you are confident about that, then you can directly represent that number. So let's say it is 1, 2, 3, 4, 5, 6, 7, and this one is 8. So our universal set is basically equal to the combination of all this up till 8. Then A set is equal to 1, 2, 3, 4. B set is given there equal to 1, 2, 5, and 6. C set is basically equal to 1, 5, 4, 7. Then here they have given us A intersection B. So we can write that thing A intersection B is basically equal to 1, 2. Because this is the region between this A and B there. And then you are going to write down A intersection B with the union C is basically equal to 1, 2 union, and C set is there 1, 4, 5, 7. So their set will be equal to 1, 2, 4, 5, 7. So 1 is this, 2 is this, 4 is this, 5 is this, and 7 is this. So directly, if you have to write down this whole part, A intersection B is basically this portion there, 1 and 2. And then union with the C means the collection of that element C with that. So it should be equal to 1, 2, 4, 5, 7, which is the required shaded region for this part there. Second phase, if they write A intersection B complement union C complement, and the same shape is given to you. Let's say it is A, it is B, it is C. A intersection B complement, in other words, means only A, but we will write it like this part as it is 1, 2, 3, 4, 5, 6, 7, and 8 there. The numbers we have assigned it to that, just like according to this figure. Now, A intersection B complement. First of all, B complement is basically there, except the element of B. B is basically 1, 2, 5, 6. So it should be equal to 3, 4, and 7, and 8 there. Now, A intersection B complement. That means the combination of A and B complement. A is 1, 2, 3, 4 with intersection of 3, 4, 7, and 8 there. So it should be equal to 1 is not common there, 2 is not common there, 3 is common there, 4 is common there, 7 and 8 is not there. So that basically it is 3 and 4 of that portion there. So this 3, the only A and this 4 is there, except B. So now A intersection B complement union C. So this is basically equal to 3, 4 with the union. C set is basically equal to 1, 4, 5, and 7. So this set will be equal to 1, 3, 4, 5, and 7. So 1 is this, 3 is this, 4 is this, and 7 is this. So it is basically this shaded region is the required region for this condition for that sets there. Suppose you have been given this shape there. A, B, and C. We write it as 1, 2, 3, 4, 5, and 6. So universal set is 1 till 6. Set A there is 1, 2. Set B there is 2, 3, 4. And set C there is 4 and 5. And you have to represent A intersection B complement intersection C complement. So A intersection B complement, that means only A. So here A is 1, 2, B is 2, 3, 4. So A intersection B complement is basically equal to 2. So that is means only A there, which represents only A part. Now A intersection B complement intersection C is equal to. Now this 2 is going to be intersected with the C 4 and 5. So there's nothing common between these two, or it is the null set. So nothing is shaded in this part there. So no shaded part is there for this required figure there. So all thing will be empty in this portion there. Suppose we have another figure there. It is A, it is B, it is C. So it is 1, 2, 3, and 4. So universal set is 1 till 4. Set A there is 1. Set B there is 1 and 2. Set C there is 1, 2, and 3. And now you are finding A complement union B intersection C complement. This is the condition given to us, and you have to shade it like that. Directly we can write it's like this. A intersection is basically equal to 2, 3, 4 outside A there. With union B, A complement union B is standing for that A complement and B will be together. So 1 is there, 2 is there, 3 is there, and 4 is there. So 1, 2, 3, 4 is this A complement union B. Now we are finding with the third condition intersection C. So A complement union B intersection C is basically equal to 1, 2, 3, 4 intersection with this element C there. And C there is only 1, 2, 3. So 1, 2, 3, 4 intersection 1, 2, 3. So you have seen it like that. 1, 2, 3 is the portion of this. So this portion will be selected there for the shaded part of this figure there. So from this, you will come to know that without getting numerical numbers, if you have the directly concept of that with the shading for the two sets and then with the third set, then you can write down this required region for this, whatever is the figure given to you, and you can write down that part there. Now in the second phase, when the figure is given to you with a shaded region and you are going to write down the condition for that. Let's say this figure is given to you. It is A, B, and C, and this portion is shaded there already. And you have to write down this condition for that part. We know in this figure, it is basically the common intersection between A, B, and C. So we can write the condition like that: A intersection B intersection C is the condition for this figure there. For the second figure, if they have given this figure, A, B, and C, they have shaded this region and they have shaded this region already there. And you have to write down this condition for that part. So we know that this is the common region between A and B. So for this first figure, we write that thing, it is A intersection B. Because you are going to collect these two shaded regions, so you will use this word union. And it is B intersection C is for this portion here. So we can write down in the combined form of this. So this with the distributive law, we can write down this as B intersection A union C there. So this is the two same conditions for that part there. If this figure is shown for that part there. We know that B intersection C is not shaded there. So you can write this thing as B union C whole complement with the intersection of A. So that means what? In other words, only A there. Fourth, this figure is shaded for that, and you have to write on this condition. Since in this figure, there is no element A shaded there, so we can write this thing as A complement intersection B union C. Because there's nothing from A element there, but B union C is combined together, but except the element of this portion which is common between A is excluded. So it should be A complement intersection B union C there. if this is the figure given to you. This is the common portion between A and B, so we can write that thing A intersection B. Because there's two sets which are disjoint, so we use it as U there, and that is the C with the common portion of that. So A intersection B union C is the condition for this part of this shape there. So these are the different figures which are given to you, and you have to write down the conditions when the shaded figure is given, and you have to write down the conditions for those shaded figures.